Hello, today I'm going to work on a problem that was on my web assign, and I'm taking Chem 2, and the question is, at this particular temperature, a 2-liter flask at equilibrium contains 2.8 times 10 to the negative 4 moles of N2, 2.5 times 10 to the negative 5 moles of O2, and 2.00 times 10 to the negative 2 moles of N2O. Calculate the K for this reaction. Okay, well, let's just say what we're trying to find here, and we know that K is actually equal to concentration of products over the concentration of reactants. Okay, so we'll keep that at the top of the, put a little box around it. Okay, just grab this. Okay, so for this, the first thing I would do would be to write out the equation. So we're left, we got, our equation is 2N2 gas plus O2 gas. Ran out of a little room here, so what I'll do is I'll write it below it, but it should really be above it. It should be right here. 2N, where is it? There it is, 2NO gas. Okay. So that would be the first thing that I would go about doing for starting out this problem. From there, you would have to find the concentration of the products and the reactants. And the way you would go about finding that is you would use what is given in the problem. You would be using, well, let's write it out. Big M is equal to moles over liter. So if we're given a number of moles and we're given the amount 2 liters, then we can easily find the concentration, which is equal to the molarity of the solution. Wow. Okay, so we'll write it out. Find this is the brackets mean concentration. Find the concentrations. So if we have N2, so finding the concentrations, we're given the number of moles, which is 2.8 times 10 to the negative 4 moles divided by 2 liters, which is equal to, let's find out, 2.8 EE, or times, that's what times means, divided by 2, which is equal to 1.4 times 10 to the negative 4. I'll write that out, 1.4 times 10 to the negative 4. I apologize again that I'm working on a very tiny whiteboard. Okay, what I'll do is I'll actually, for the reactants, I will use a, I will use the blue marker. For the products, I will use a green marker. So next up on the block is O2. Oh, my apologies again. So everybody can potentially read it. Okay, so going back to our question, it is told to us in our that our we have 2.5 times 10 to the negative 5 moles of O2, and it's under the same condition again, 2 liters. So 2.5 EE negative 5 divided 2. This comes out to 1.25 times 10 to the negative 5. Okay, so I apologize, and I'll just bring it into you guys a little bit so you guys can see what. Now this is the products, or sorry, this is the reactants. Now I'll switch over to a green marker to make my life a little bit easier for everybody, and well, mine and everybody else's life a little bit easier. And I will do the concentration of N2O and in green, sorry. Okay, so now we're given concentration of N2O. So we're given the number of moles of N2O, and we'll do the same exact equation that I have been doing for the last couple. So for that, we have 2.00 times 10 to the negative 5. Sorry, 10 times 10 to the negative 2. Can't really read that well. Divide, again, 2 liters, because it says that at all for a particular temperature at 2 liters, so everything's going to be divided by 2 liters, because that's the equation for for molarity. Apologies. Negative 2 divide 2, which comes out to be 0.01. This is all big M for all of these. Okay, so now that we have the molarity, which is equal to the concentration, so I'll actually write that down for you guys. M is equal to concentration. Okay, so now we have to go, I'll finish the rest of the problem. An orange marker. It's going to make my life, again, a little bit easier. I hope that you guys can read the orange marker very well. Okay, so now we have everything that we need. So I'll write over here and like a little, the orange isn't really going to work. I have a black marker for everybody. Let me just erase all that. Just cover my markers. Okay, so now I'm going to just draw a little line. Okay, so now that we have the concentration, I'll write everything here. N2 is equal to 1.4 times 10 to the negative 4. O2 is equal to 1.25 times 10 to the negative 5. And N2O is equal to 0.01. Okay, so now we need the equation that I wrote in the beginning of the question. At the beginning of the question, it's products over reactants. Okay, so now K is equal to, now this part gets a little tricky. You need to pay attention to the stoichiometry of the equation. So actually I should probably, let me rewrite the equation down here a little bit. I'm kind of running out of room here. N2 gas. Let me start over here a little bit so we can fit it all in this time. 2N2 gas plus O2 gas is 2NO, sorry, 2 gas. Okay. So now you have to pay attention to the stoichiometry of the equation, because when you're dealing with K, which is equilibrium constant, you need to pay attention to when you see these go, instead of being those go to be like, you square it instead of so like I don't know how to really explain it. So like this question, so like when I write this, it'll become squared. So let's write it out. K is equal to products. This is our products. All right, to follow through. So it's going to be N2O squared, because there's a 2 here, divided by, again, just to fall in line, N2 squared, again, because there's this 2, O2, which there's no 2 here, it's just a 1 coefficient. That's the word I was looking for, coefficient. So, so you don't need to raise it to anything because it's 1. So let me switch back to my black marker. So we got K is equal to, and now again it's products over reactants, so it's going to be 0.01 squared over concentration of N, which is 1.4 times 10 to the negative 4. Oop, my apologies. Squared. 1.25 times 10 to the negative. Let me erase this and bring it over here a little bit so I can fit it in. Okay, and 2 is 1 squared over 1 times 10 to the negative 4 squared times 1.25 times 10 to the negative 5. Okay, so now what I like to do is, instead of doing it all in one step, I like to break it down. I'll do the squares and the multiplication first, and then I'll leave myself with this squared over this squared times this, just so I make sure that I don't skip anything. And so type into my calculator, squared, which comes out to 1.0 times 10 to the negative 4. Put the little brackets to mean concentration again. And now for the fun part. It's just so everyone can see. I'm going to do 1.4 e to the negative 4. Just make sure that I followed through okay. Yeah. Squared is that. Is 1.96 times 10 to the negative 8. And multiply that by 1.25 times, to the negative 5. Get rid of that. Comes out to this concentration is going to be 2.45 times 10 to the negative. My apologies. 2.45 times 10 to the negative 13. Okay. From now, what I'll do is I will take 1.0 e to the negative 4 times 10 to the negative 4 and divide that out by 2.45 times 10 to the negative 13. And I get a large number, 4081 6 3. Sorry, I'm dyslexic. 265.3. Okay, so now to simplify that answer down, we'll have to do some elementary algebra. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now this equation is going to be 4.08, because this doesn't round up, times 10 to the 8th. Okay, all done.